Hey everybody, in this video we're going to go through the definitions for chapter 5. This is all the stuff that we're going to be covering throughout the chapter, and then we're going to be focusing on perpendicular bisectors and angle bisectors. Okay, so first you're going to go over this assignment here, as you can see the heading, and then we're going to go through perpendicular bisectors and then the angle bisectors. So you want to have these two assignments out. Okay, so the first vocabulary term is a midsegment. A midsegment is a segment that joins the midpoints of two sides of a triangle. Okay, so over in the picture below, what we're going to do is find the midpoint of two of the sides. So we're kind of estimating here, but we're going to put all the markings. So if that point right there is the midpoint of AB, we're going to put tick marks. Let's call this point D. And then we'll find the midpoint of segment BC. And we'll call that point E. And we'll put the tick marks over there as well. And then we connect the midpoints. Okay, so that's what a midsegment looks like. Okay, a perpendicular bisector, which is one of the topics we'll talk about today. A line, segment, or ray that divides a segment into two congruent parts and it is perpendicular to that segment. Okay, so it looks something like this. We find the midpoint of one of the sides. So in this one, I'll find the midpoint of AC. So I'm just kind of estimating. We'll put the tick marks. We'll put a point, let's call this point D. All right, so that's the midpoint. So AD and DC are congruent, and it's going to be perpendicular to D. So it looks something like that. So that's what a perpendicular bisector looks like. Okay, the next one, an angle bisector. A line, a segment, or a ray that divides an angle into two congruent parts. So pick any angle here. We have angle A, B, or C. I'll do angle B. I'm going to try my best to cut that into two congruent parts. And to show that I made them congruent, I'll put an arc mark in each angle. That's what an angle bisector looks like. All right, the next one, a median, a segment that connects a vertex of a triangle to the midpoint of the opposite side. So pick any vertex here. I'll pick vertex B, and I'm going to connect it to the midpoint of the opposite side, which is side AC. So the midpoint is right in the middle of A and C. I'll put a tick mark on both sides to show that it's the middle, and I'll label this as point D. Connect those, and that's what a median is. Okay, the next word is an altitude. An altitude connects a vertex of a triangle to the opposite side so that it is perpendicular to that side. Okay, so in this case, I'll pick B again. That's a vertex, and I'm going to draw a line that's perpendicular to AC. And to show that it's perpendicular, you want to put the box, the right angle box. Altitude you often hear maybe with the height of an airplane or how high you are up on a mountain. It's always perpendicular to, let's say, the ground, for instance. Okay, the circumcenter, the incenter, the centroid, and the orthocenter. These are all called centers of circles. They're intersections of different lines, and it's the lines that we just talked about above. Okay, so a circumcenter. If you look at the picture, you can kind of tell what it is. You can tell that XM, YM, and ZM are all perpendicular bisectors. So it's the point at which the three perpendicular bisectors intersect in a triangle. An incenter, the point at which the three angle bisectors intersect in a circle. So from the picture, you can see that angle B is being bisected, angle C is being bisected, and angle A are being bisected, and they all intersect at point M. That's called your incenter. Okay, the centroid. The centroid is the point at which the three, that would be medians, intersect. So BZ is a median because it goes from a vertex to a midpoint. AY goes from a vertex to a midpoint, so that's a median. And then CX goes from a vertex to a midpoint. They all intersect at M, so M is called your centroid. All right, and then your last one, the orthocenter, that's the point in which the three altitudes intersect. All right, just a couple of little notes that I want to make. The circumcenter, notice the word circum. That means like kind of like the circumference, the distance around. So what that means is if I was to draw a circle containing point A, B, and C, so I'm just kind of doing a rough circle there. M would be the center of that circle. The incenter, that would be if I drew a circle inside of that triangle. It only touched each side. So I'm just kind of sketching it. M would be your center of that circle that's in the circle. That's where you get the in center from. And then the centroid, just to make a little note, it's also called the center of gravity. So if you were to take that triangle right now and try to balance it, you would want to put your sharp point, like a pencil point or something, right on that point, and that triangle would actually balance perfectly. It's called the centroid. Okay, so now we're going to focus on two specifics today: perpendicular bisectors and angle bisectors. So what I'll do is I'll go through these notes. I'll do a couple of examples, and I'm going to leave 8 examples blank for you guys to do. Okay, so the first definition here, the perpendicular bisector theorem. So if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So here, we're looking at segment AB. So I'll highlight that. CD is a perpendicular bisector. So I'll highlight that. What that says is that any point that's on the perpendicular bisector, which in this case is point C, it's equidistant from the endpoints of the segment. So C is equidistant from A and B, making AC congruent to CB. So if CD is perpendicular to AB and AD is congruent to DB, then AC is congruent to BC. Okay, then the converse of that statement says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So in this case, they're saying that point C is equidistant from B and A. So since C is equidistant from the endpoints of segment AB, what that means is it means that CD must be a perpendicular bisector. So that means that CD and DB are perpendicular, so it would actually make a right angle, and it means that AD is congruent to BD. So that's called the converse. Notice we just flipped the hypothesis in the conclusion. So if AC is congruent to CB, then CD is perpendicular to DB, and AD is congruent to BD. Okay, so let's take a look at a couple of examples. So number one, find the value of x. So from the picture, we have this segment, and then we have a line that's perpendicular to that segment, and it's hitting that segment at its midpoint, and the way we know is because it has the tick marks. So this is this picture right here. It's a perpendicular bisector because it's got the right angle box, it's got the tick marks, and remember, if a point is on the perpendicular bisector, then it's equidistant from the endpoints. So that means that this segment is congruent to this segment. Okay, so we're going to just set them equal and solve for x. Okay, so there's our equation. To solve this one, subtract the 7x from both sides, and we get 6x, and then add 48 to both sides, you get 72. Then you're going to divide the 72 divided by 6, and you'll get x is 12. Okay, in this question, it just said to solve for x, but if we do take that x and plug it in, 7 times 12 plus 24, you get 108. And then same thing here, 13 times 12 minus 48, I also got 108, which makes sense because this point should be equidistant from the endpoints. When you get down to the ones down here, so we're actually going to leave 3, 4, 5, and 6 for you guys to do. This is going to be your assignment for the day. When you get down here, it's actually asking you to find the length, so you'll actually need to plug it back in and make sure that these are equal to each other. Okay, number 2, find the value of x. So this one's the converse. So in this case, this point here is on this segment here. This point here is equidistant from the endpoints of the segment, meaning that this line here must be a perpendicular bisector. So we can put the right angle box, and we can also put the tick marks. And now we know that our equation is going to be 17x minus 3 equals 9x plus 13. To solve this equation, subtract 9x from both sides, and we get 8x. And then add 3 to both sides, we get 16. Divide by 8, and you get x is 2. Just a good habit, plug that 2 back in. 9 times 2 is 18. And then 18 plus 13, that's going to give you 31. Which means that this part should also be 31. So if we do 17 times 2, we get 34. 34 minus 3 is 31. So now we know we got our answer right. Okay, so you guys are going to finish up 3, 4, 5, and 6. Okay, so flipping over to the back, we'll talk about the angle bisectors. So an angle bisector looks like these pictures. This picture here, the angle bisector theorem says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So in this case, point C or point D is on ray AD. Ray AD from the tick marks, or I'm sorry, from the arc marks, you can see it's an angle bisector. It's cutting the angle in half. Therefore, DB must be congruent to DC. That's what the angle bisector theorem says. So DB is congruent to DC. Conversely, we can say that if a point is on the interior of an angle and is equidistant from the sides of the angle, then the point is on the angle bisector. So in this case, D is in the interior of the angle. It's equidistant from the sides of the angle. That means that angle BAD is congruent to angle CAD. That's the converse of the angle bisector theorem. Okay, so let's take a look at 2 examples. So example 1, find the value of x. So in this case, we have an angle bisector. We see the arc mark, so we know this is an angle bisector. This point is on the angle bisector, which means it's equidistant from the sides of the angle. So that means that those 2 distances are the same. So we're going to set those equal. 9x minus 5 equals 4x plus 30. To solve this one, subtract 4x and we get 5x. Add 5 and we get 35. And then divide by 5x is 7. Take that 7, plug it in. 9 times 7 minus 5. That's going to be 63 minus 5, which comes out to be 58. 7 times 4 is 28. 28 plus 30 is also 58. And they're equal, which they should be, because this point should be equidistant from the sides of the angle. Okay, and then number 2, that's the converse. So in this case, here's our angle. This point is on the angle, or on the interior of the angle, and it's equidistant. We see that from the tick marks. It's equidistant from the sides of the angle, which means this must be an angle bisector, making this angle up here equal to this angle down here. So that means 8x minus 41 equals 5x minus 11. So to solve this one, subtract 5x from both sides, and we get 3x. Add 41 to both sides, and we get 30. And then divide by 3, and we get x is 10. Take that 10 and plug it in. 5 times 10 is 50, and then 50 minus 11 is 39. So that's a 39-degree angle on the top. So that means the bottom should also be a 39-degree angle. So if we do 8 times 10, we get 80. 80 minus 41 is 39. So it is true that this is an angle bisector. Okay, so you guys are going to work on number 3, 4, 5, and 6. Okay, so that's your assignment for today. With that being said, if you guys have any questions, please make sure you send an email or come on to Google Meet between 9 and 11 and you can chat with Ms. Rinaldi and I. If something isn't technically working, just shoot us an email. We'll figure anything out for you. We can be lenient with you. Just make sure you do reach out and keep on top of your work. All right, have a great day, everybody.